Hello and greetings. This is a showcase of the project that we did as a group assignment for Inc. 1330 computer programming class. In this video, I'm going to walk you over the gameplay and the coding implementations of this project. So let's just get started with the main script. So to give you a little context, we took inspiration from the classical traditional Chinese game called Nim game, and we have added an extra flavor to it where the Nim San, the name of the game, here San means three in Chinese. So the setup of the game looks something like we have three stacks of coins, and we have two players each taking turn to remove certain number of coins from exactly one stack. And these actions of taking X number of coin will be driven by a motivation to obtain a final optimal state. And this final optimal outcome will look differently for the different mode that we have. So more on that a bit later. Let's just choose a number to generate our piles, and then let's choose to start first. And then here are the two modes that we can select. In mode normal, the one to pick out the last coin wins, and in misery rule, the one to pick out the last loses. So the objective would be to force the opponent to pick out the last coin. So let's just play the easier one, normal, and this has all the rules of the game. And this is a visual representation of the game state, where this is pile 1, pile 2, pile 3, and the number of coins each pile has. And now let's just do play the game. I take three coins from pile 1, computer analyzes. I take from pile 3, one coin, computer analyzes. I take from pile 3, one coin, and again pile 3 from coin 1 from pile 3. And now this is the only coin remaining, so we just pick it up and we win. So if you see carefully, I have employed a definite strategy to win this game. So in each of the moves that I make, try to make sure that the nim sum of the state that I'm handing over to the opponent yields a 0. So the nim sum is a XOR of the game states. So game state here is 0, 2, and 2. So the XOR of this is 0. So that's the winning strategy derived from a theorem called Sprague-Grundy theorem from game theory. And similarly, we can try playing mode 2, which is misery, where the last one to pick out loses. So again, let's just do this. We play, yes, we want to play misery. It wants us to initialize pile 1, 3 coins, pile 3. Let's just pick one coin from pile 3, one coin from pile 3. And now here, we can't use the same strategy as we did in the normal, because if we take one of these, then the computer will take this and will be forced to take the last one. So in this case, I will force the computer to take the last one by removing all from the 3, and I win. So this was the gameplay. As for the code, I can show you around. We have made our program very modular, which makes it easier to read. We have adopted best practices of OOP using classes and objects, and a very solid and robust state management, which makes it readable, faster, and efficient. And and a lot of GUI prints and logs to make sure that the UI is appealing, and a lot of inputs from the user. This is a game state class, and this is game state object. This is the computer player, um, which has a pick move method to it, which will pick an optimal move depending on the mode that we have selected. So this move, as we can see, it does a lot of calculations. It calculates the XOR of the states and tries to hand off a nim sum of 0 to the opponent. Similarly, for the misery one, there are a few extra conditions where if we have one pile with size 1, then we do it differently, so on and so forth. But yeah, so we run an infinite loop, and it alternates between the human player and computer player, and the computer player tries to play optimally. And we also have a very comprehensive README file where we have laid out that the core concepts of maths and CS that we have used are like Sprague-Grundy theorem, XORs, which might also include MEX, minimum excluded. And I think that was it. Thank you very much. Hope you liked it.